Hello, this is Professor Broker, and this is your Chapter 5 lecture, Part 3, about elasticity for Econ 231. Let's get started. Remember, we were talking about elasticity, and we said the basic idea is how one variable responds to changes in another variable. Okay, we were mainly looking at how quantity demanded changes in response to some of its determinants, mainly price. We called that price elasticity of demand when we were measuring the percent change in quantity demanded over the percent change in price. Remember, we calculated those percentages using the midpoint method. Okay, and again, we were measuring buyer sensitivity. Okay, now there's something else we want to talk about here is we want to talk about price elasticity and total revenue. Remember, total revenue can be calculated as price times quantity. Okay, now what happens if the price goes up for a firm? A firm decides to raise their price. Will their revenue absolutely go up? Well, the price increase would be a positive force on their revenue, but remember, because of the law of demand, they would sell less of their product, right? And so you would have an increase in price that would positively impact revenue, but the quantity would have a negative impact on revenue. So what would actually happen to revenue when you increased price? Well, to answer that question, we would need a measurement of how responsive quantity is to a change in price. Good thing we have one called elasticity, right? And so, again, it's going to the answer to that question is going to depend on the price elasticity of demand. So that's what we want to look at next. Okay. And again, let's just think about this intuitively. If demand is elastic, okay, let's think about what that means. If demand is elastic, that means that this formula is greater than 1. That means the percent change in quantity is greater than the percent change in price. So think about what would happen, right, if price increases. If the price increases, okay, that would be a positive impact on revenue, but the quantity would decrease, and because the price elasticity of demand is elastic, the quantity decrease would actually be much bigger than the price increase. So the overall effect on revenue would be negative, okay, because the demand is elastic. Okay, so let's look at an example of this. We have elastic demand here of 1.8. There's a website firm that's charging $200 per website. They manage 12 websites at a price of $200, and therefore their revenue is $2,400. 200 times 12, $2,400. They raise their price to $250. Okay. What would that do to their revenue? Well, obviously they would lose some customers. Let's just say 4. So now they'd only have 8 websites. Okay. They would have some positive increase on their revenue from this higher price. The 8 returning customers would pay a higher price for their website, represented by this yellow rectangle, but they would lose the revenue of these 4 customers, okay, the customers that they lost. And so the question is the revenue they gained bigger or smaller compared to the revenue they lost? Well, let's see, right? The lost revenue, okay, would actually looks like it would be bigger than the increased revenue. Okay, therefore, when demand is elastic, a price increase will actually cause revenue to fall, and we see that here. The revenue would go from 2,400 down to 2,000. So even though they raised their price, their revenue would actually go down because of the elastic elasticity. Okay, now if none of that really made sense in the last couple of slides, it's okay. You're not alone. And I have a very, hopefully, simple way for you to remember, to commit to memory, that when you have elastic demand, the revenue, okay, and price move in opposite directions. Okay, I want you to think about elastic demand as a seesaw. Okay, elastic demand as a seesaw, right? And think about price and total revenue getting on opposite sides of the seesaw. When you have elastic demand, you have a seesaw, and if price is on one end and it goes down, what happens to the other end of the seesaw? It goes up, right? So price goes down. If you have elastic demand, your total revenue would go up. Well, think about it in reverse. If your price goes up, okay, you increase price as a business, but you have elastic demand, what would happen to your total revenue? It would go down. Okay, so again, think about a seesaw and price and total revenue moving in opposite directions. That will help you answer these questions. Okay. Now, think about it. Let's think about another case. What about if you have inelastic demand, right? Well, again, what does that mean? That means that the numerator here, the percent change in quantity demanded, is smaller than the percent change in price. So if I increase my price, that would have a positive effect on revenue, and my quantity would go down, but not by very much, not if I have inelastic demand. So the negative impact would be very small. Therefore, the net effect would probably be a positive impact on my revenue, right? So again, the fall in revenue from lower quantity is smaller than the increase in revenue from the higher price, so revenue rises. Let's look at an example. Let's go back to the same website example. I have 12 websites I design. I'm charging $200 per website. My revenue is $2,400, but now my elasticity is less than 1. Therefore, it's inelastic. It's 0.82. Okay, what would happen if I increased my price to $250? Well, this time I would only lose 2 customers because, again, buyers aren't very price sensitive because my elasticity is 0.82. Maybe they don't have a lot of substitutes. Maybe my quality of service is very high. For whatever reason, I don't lose a lot of customers. Therefore, the revenue that I lose represented by this rectangle would actually be smaller than the revenue I gain from the higher price. Therefore, my revenue actually goes up from $2,400 to $2,500. Now, if none of that made sense, you're not alone, but I'm going to give you a very simple example to help you remember. When price and total revenue, okay, what happens to price and total revenue if you have inelastic demand? I want you to, okay, when demand is inelastic, price increases cause revenue to rise, but how can you remember that? I want you to think about inelastic demand as getting in an elevator. Inelastic demand getting in an elevator. Okay, if price and total revenue both get in an elevator, right? If one of them goes up and they're both on the same elevator, guess what's going to happen to the other one? They're also going to go up, right? Price and total revenue, if it's inelastic, they get in the elevator together. Guess what? They're both either going to go up or they're both going to go down, right? They can't move in opposite directions. And so inelastic demand, think about getting in an elevator. They go in the same direction. If you have elastic demand, think about getting on a seesaw. Price and total revenue move in opposite directions. Let's practice. Okay, pharmacies raise the price of insulin by 10%. What would happen to total revenue? Okay, for the pharmacies, well, again, price is going up. Think about the elasticity for insulin. It's probably elastic or inelastic. Again, insulin's probably inelastic because it's a necessity. Therefore, we're going to get in the elevator together. And if the price goes up, guess what? Total revenue is going to have to go up. Okay? Again, pharmacies raise the price of insulin, total revenue, and price would get in the elevator together because insulin would have inelastic demand. Therefore, we would expect revenue to rise in this case. Okay. What about if the price of luxury cruises falls by 20%? Luxury cruises would probably have elastic demand because it's a luxury. We would expect price and total revenue to be on a seesaw. Therefore, if the price falls by 20%, we would expect revenue to actually rise for the firm. Okay. And then finally, Dunkin' Donuts runs a daily afternoon special with half-price coffees. If the demand for their coffee is fairly stable, meaning people are going to buy afternoon coffee regardless of what they charge for the price, therefore it's inelastic, what is happening to their revenues on a daily basis? Again, if this is inelastic demand, they're getting in the elevator, and if the price falls, guess what happens to their revenue? It also falls. Okay? Now, we've talked about price elasticity of demand, some of its determinants, how to calculate it, and we've also talked about how it relates to revenue. But there's some other elasticities to think about as it relates to demand. Namely, we're going to look at cross-price elasticity as well as income elasticity. So the price of the good we're looking at is, so if I'm looking at how consumers respond to a change in the price of pizza, the price of pizza is not the only thing that influences my demand for pizza. The price of a burrito would also influence my demand for pizza because that would be a potential substitute for lunch on a given day, right? And so this would be a cross price. As the price of a burrito changes or a burger changes, how does that influence my demand for pizza? That would be a cross price elasticity. Okay, it's measures the response of one good to the price change of a related good. Okay, and so we're going to have the percent change in quantity demanded for good one, say pizza, in the numerator, and the percent change in the price of hamburgers or burritos in the denominator. Okay, that's what we're going to look at. And so let's just say it's beef and chicken, right? If the price of beef goes up, what would we anticipate might happen to the demand for chicken? That's what we're looking at, right? If the price of beef goes up and people buy more chicken, that would make this a positive number, and that would also indicate that consumers are viewing beef and chicken as substitutes, right? Because as the price of beef goes up, people are buying less beef and more chicken. We can also think about it, though, if the price of beef goes up and people buy less chicken. So this would be a negative numerator, right? Then we would tend to think that then maybe beef and chicken might be more like complements, right? Because this would be, people would be buying them or not buying them in tandem, okay? And that would be something to consider. Okay, so again, for substitutes, we would expect this cross price to be greater than 1. Again, the price increase of beef would probably it would probably increase the demand for chicken. Price increase of beef would increase the demand for chicken, making this a positive number, which would make it a positive cross price elasticity, which would indicate a substitute. Okay, as opposed to, say, Keurigs and K-Cups. If the price of Keurig machines goes up, we would anticipate that people would actually buy less K-Cups, right? Because, and again, that would indicate that people are buying these two goods in tandem. It would make this cross price negative, and that would indicate that these two goods are probably complements. Again, substitutes and complements is something we talked about in Chapter 4. The cross price elasticity can actually give us some numerical precision to that concept. So if I'm a store owner, if I'm the manager of Walmart, I can actually run these cross prices with my data that I have, and it would be probably helpful to know, what are my complements in my store. I probably want to put those next to each other in my store as opposed to maybe my substitutes. And so it would be good to know which of my goods are substitutes, which are complements. The cross price elasticity would tell you if it's negative, they're complements. If it's positive, they're substitutes. Another type of elasticity would be income elasticity. Okay, this would measure the percent change in quantity demanded as income changed, or our percent of income changed. Okay, so let's look at, for example, eating out. If the average incomes in Murray went up, what would we anticipate would happen to the percent change in quantity demanded of eating out? Well, if they're normal goods, then we might expect this elasticity to be greater than 0, because we would expect that as income goes up, the quantity demanded for eating out would go up. Therefore, this would be a positive fraction. Therefore, if the income elasticity is greater than 0, that would indicate that it's a normal good that we talked about from Chapter 4. Now, that's different from goods, for example, maybe like Spam, right? So for Spam, if your income goes up, my guess is you're going to actually buy less Spam, not more. Okay, that would make this a negative number, a negative fraction, and if it's a negative fraction, that would be an indication, again, that our income elasticity, when it's less than 0, that would be an indication of an inferior good that we talked about from Chapter 4. So again, income elasticity from Chapter 4, we can add some precision to that concept with the income elasticity. If the income elasticity is greater than 0, if it's greater than 0, it would be a normal good. If it's less than 0, it would be an inferior good.